Trans-Alaska Pipeline made history when it came online 40 years ago, and it continues to play a major role in shaping Alaska's future. We're going to take you behind the scenes of this engineering marvel. We begin by meeting some of the folks who overcame incredible obstacles to build the pipeline pioneers. It winds its way across 800 miles of the Great Alaska Wilderness, and the path it traced 40 years ago pointed the last frontier to a new, more prosperous future.
There are few things in Alaska's history that equal the magnitude of the impact of the pipeline. The money that it brought in was unimaginable.
It was controversial and embattled at the start, but now even some of the strongest opponents from years ago praise its track record.
Considering the magnitude of the project and the rocky start that it got originally, I think it has done very well.
Despite new technical challenges, the people who run the pipeline are fueled by optimism.
There's a lot of good news stories. We're getting more and more oil into the system.
And there is great pride about the 40th anniversary. The first sections of the Trans-Alaska Pipeline were laid in March of 1975. The final weld was completed just 2 years later. It had to cross 3 mountain ranges and 30 major rivers and streams.
Welcome. I'd like to introduce you to my museum. Normally 25 cents admission fee, but for you folks, we'll give you a special deal.
Dave Haugen was there from the very beginning. His home office is decorated with pipeline memories.
Just as one of my mementos I keep treasured to this day is this particular old flannel shirt right here, because here I am, 1975, during the original construction at Delta Camp. And as you can tell, a little bit younger, a little bit more hair, and not so much white hair as now.
Back in 1970, Dave was one of the surveyors who laid out the route for the pipeline from the Yukon River to Valdez. Dave became a project manager and tackled some big challenges, like the pipeline bridge over the Tanana River.
The entire project was monumental. For those of us that were on it, we knew that when we were doing the project that it was going to have historical significance.
And the costs were also historic. The original construction estimate, $900 million, but the final price tag climbed to $8 billion, or $32 billion in today's dollars, the largest privately funded construction project in history at that time. And it would take 70,000 people to make it happen.
Good memories, a lot of work, very tiring. 15, 16-hour days pouring concrete.
Scott Harder signed on as a construction laborer in 1975.
This was my crew in the pipe.
That's cool.
Well, I signed on because it was pretty good money. And I also got to travel around the state and see some places that I hadn't been before.
Places like Adigan Pass, the highest point on the pipeline route. Scott and his buddies poured concrete in one of the toughest sections of the whole project.
40 years, it's just, it's impressive. Every time I drive down the Richardson Highway and I see the pipeline, it's, you know, it's a sense of pride that I was involved in building that, and it's still pumping oil and still helping Alaska and the United States.
Current weather at Chandelar. Temperature is 0.
Pipeline workers lived in remote camps up and down the construction route. Clara King left her home in Houston, Texas to work on the pipeline. Clara says she'll never forget the day she arrived.
And we landed at Franklin Bluffs. It was 69 below and ice fog. Wow. And when we got off the plane to walk over to the camp, 6 people got back on the plane and said, "I'm not staying here."
But Clara stayed and found job opportunities not usually open to women back then.
I was extremely excited because they had women in every capacity, which they'd never had on a pipeline before. It had always been a man's world, laying pipe.
People like Clara King, Scott Harder, and Dave Haugen, and thousands of others were pipeline pioneers. And at the end of the pipeline in Valdez, there's a monument to the construction workers that carries their motto, "We didn't know it couldn't be done." It's a testament to the people who 40 years ago did what many thought was impossible. They built a project that helped build the Alaska we know today. The Trans-Alaska Pipeline depends on heat to keep the oil flowing, but engineers are now fighting a cold war to keep the pipeline from plugging up. There's a battle going on at Pump Station 9 near Delta Junction.
So we're entering the manifold building.
And this is the war room. Pump Station Supervisor Wes Wilson takes us behind the scenes to a place that is extremely rare for visitors to see, where even most pipeline employees can't go.
We're walking into the main manifold section. We're seeing the launcher and receiver.
Around the corner is where one of the most hazardous jobs in the pipeline system takes place. A dirty, dangerous procedure that has become crucial as the amount of oil flowing through the line has dropped.
This is the launcher for our pigs that we send to Valdez every 7 days.
And this is their battle-tested weapon, keeping the pipeline from getting plugged up. It's called a pig, a cleaning device that's about the size of a compact car. They're launched into the pipeline, get pushed along by the oil flow, while scraping out wax that naturally occurs in the oil when it comes out of the ground.
If you didn't do this, what would happen to the pipeline?
If you didn't do this, eventually over time you would start to build up a larger and larger layer.
That black stuff on the pig, that's the wax that's scraped out of the pipeline, and this is only a very small portion of what gets pushed out.
It's a very dirty job to begin with. Our last pig pull that we had, we recovered 9 barrels of wax from that. That's about 1,600 pounds, and that's fairly typical.
But about a year ago, something happened that was anything but typical. When they opened the hatch, they couldn't see the cleaning pig at all. It was being blocked behind a giant solid plug of wax.
71 barrels on that one. It took us about 4 days. We had to bring in additional resources to do it.
And it's tough, dangerous work. Crews must use spark-proof shovels to dig out the wax, because one spark could trigger an explosion. The wax problem has gotten significantly worse during the past several years. Here's why. The oil is around 100 degrees when it comes out of the ground at Prudhoe Bay. Years ago, when flow was greater, it stayed at about that temperature and the melted wax just flowed right along with it. But less oil in the pipeline now means the oil is moving a lot slower. It used to take just 4 days to travel from the North Slope to Valdez. Now it takes almost a month. That gives it more time to cool off. The oil can now dip below 40 degrees in winter. For decades, engineers didn't have a way to actually see the oil flowing inside the pipeline, so they could study the wax problem and come up with solutions. But that has changed. Engineer Jacques Thibault, who's on a special team looking at ways to keep the pipeline operating into the future, shows us a new device that went online just within the last year. It's a powerful camera and light system that can peer into the oil stream to see what's in it.
At this location we have 3 different sample locations, so we can look at flow from the top of the pipe, the middle of the pipe, or the bottom of the pipe.
The camera can see microscopic particles of wax and water droplets in the oil in real time.
This is critical. This is the first time that we've ever had a chance to actually see what's going on inside the pipeline.
Water that's in the oil when it comes out of the ground is also a big problem. With less oil flowing, water can collect and cause corrosion. If it freezes, the ice can jam critically important safety valves.
So this is our recycle skid. This is what's helping us add heat during the winter months.
To try to warm up the oil, 3 pump stations now send it through an extra series of pipes at a rate of 12,000 barrels per hour. The extra friction adds heat.
I think some of the technical challenges right now that we face are as challenging as some of the technical challenges that engineers faced in the very beginning.
But just like 40 years ago, the people of the pipeline say there's not a challenge they can't meet or a problem their optimism and determination can't conquer to keep the oil flowing and the pipeline going. The equipment used to control the Trans-Alaska Pipeline when it came online 40 years ago would be considered technological antiques today. There have been some big changes and big debate about automation that's now being used to keep the oil flowing and to prevent a potentially disastrous oil spill. The Trans-Alaska Pipeline stretches from one end of Alaska to the other, 800 miles of 48-inch diameter steel pipe.
Hey, Ryan 1 is 10. Copy that, thank you.
So you might be surprised to learn this massive pipeline is controlled from one relatively small room hundreds of miles away. It's here in Anchorage. We wanted to see how it all works, and we were granted rare behind-the-scenes access to the electronic heart of the entire Trans-Alaska Pipeline system. It's in a highly restricted building, so much so we were asked to not disclose its exact location because of security concerns.
Are you going to start walking up now? It looks like you're stabilized.
From just 3 monitoring stations, a handful of operators watch and control the entire pipeline around the clock with mouse clicks.
Can I get a time, level, and temp? Tank 56.
Stand by.
They also have instant voice contact with crews along the line.
Automations is very helpful because we can set parameters that the normal conditions operate under, and if it gets outside of that, we'll get alarms and then we can investigate that.
From Anchorage, they can even fill and empty the huge storage tanks at the Valdez terminal. Sensors constantly measure the amount of oil going in and out of the system and pressure within the pipeline. And if the numbers don't add up,
the controllers here have everything they need to be able to isolate facilities, to emergency shutdowns, as well as safely start up the system.
The Operations Control Room, or OCC, went online in January of 2008. It's a key part of what Alaska Pipeline originally called strategic reconfiguration that began back in 2001.
And really, the goal was to position ourselves for, continued operation kind of indefinitely.
Miles of intricate wiring and sophisticated computers direct all internal operations.
For about the first 30 years, each pump station had its own control room that looked like this, but they could only control a section of the pipeline.
It was a needed upgrade to the system. We were running on older technology.
So during the last 10 years, pump stations were automated. Their old control rooms were shut down, and oversight was shifted to the Anchorage complex.
The people in the field have really shifted their focus less about operations and more about the maintenance and response capabilities if there ever was any sort of an upset condition.
But the changes have upset some environmentalists.
So now they've got fewer people actually in the field on the line looking for incidents. And so that's one of our big concerns, is the automation of the pipeline.
Kristen Carpenter, executive director of the Copper River Watershed Project, worries that too much faith is being invested in automation.
As far as our oil spill response capabilities, we have not changed that.
Hillary Schaefer has seen a lot in her 20 years spent working on the pipeline. She was in charge of the cleanup plan in 2001 when a drunk man with a rifle fired a bullet into the pipeline north of Fairbanks. Schaefer is now in charge of making sure crews along the pipeline are ready to respond to a spill. And she says automation has not come at the sacrifice of preparedness.
We have an approved oil spill plan. We have the same number of responders and the same amount of equipment to respond to any situation.
But critics say the pipeline has gone from having 11 pump stations when it was built to 4 now that are automated. And they contend with fewer staff pump stations, detection and response to a major spill would take longer.
The worry is that, to my knowledge, there isn't any spill that's ever been detected by other than human observation.
The company claims its automated systems can detect and head off dangerous problems even faster than human operators.
The other one's probably close, right? Because they're all cascade off of the JIC.
The people who run the pipeline acknowledge that automation will never replace the human factor. The dedication of the people who want to see this 800-mile engineering marvel go the distance for decades to come. It's the last stop for oil that flows through the Trans-Alaska Pipeline before heading to refineries in the lower 48. The Valdez Marine Terminal plays a big role in this system in a very big way. It's perched high above Valdez Harbor on a site blasted out of the mountainside.
It's actually almost 1,000 acres, the size of the area of the facility here.
And that's what grabbed our attention as we went behind the scenes at the Valdez Marine Terminal. Everything here is huge.
Typical tank is 60 feet tall, 250 feet across. They'll hold 550,000 barrels.
And there are 14 of them in use today. They can hold more than 7 million barrels of oil. That's enough to fill 445 Olympic-sized swimming pools. From the water to the very top, the terminal rises 660 feet above sea level. That's the height of a 60-story building. Down below, the docks where the tankers load. The largest can hold 2 million barrels. The whole complex is so big it has its own power plant that uses oil vapors from the big tanks for fuel.
It's almost an engineering marvel, and construction was state-of-the-art at the time.
But a lot of time has passed since all of this was built, and there's a lot you can't see, like hundreds of feet of underground pipe, much of which went unchecked for the past 40 years because it was too steep for inspection equipment to navigate. That's where Alice and Dee and several of their friends come in. These robots are now being used to crawl inside the pipe on little tank treads, and they can expand and contract to maintain a good grip.
Over here, this is how we drive the robot. There's 5 camera views.
They're checking for cracks and corrosion in pipes that haven't been seen since they were welded together and buried more than 4 decades ago. Lasers and ultrasound sensors look for flaws.
You can inspect 100% of the pipe for defects, corrosion, anomalies, dents, anything else we can find.
During our behind-the-scenes tour, we saw pipes that were cut and plugged. These pipes used to move oil to and from the 4 highest tanks. Tanks which were shut down in 2013 because less oil was flowing from the North Slope. That's not the only big change here. One of the major problems now is snow. Years ago, they didn't have to shovel the tops of the tanks. The oil was at 100 degrees when it reached Valdez, and the heat melted the snow away. But less oil means colder oil and a lot of back-breaking work to keep the tanks from collapsing under the weight of snow.
Up on top of the tanks, a crew of between 10 and 11 people would take almost a full week to fully move the snow off of one tank, and so it just went from tank to tank. And
several people we met who work at the terminal are from communities around Prince William Sound.
3rd generation commercial fishing family, yes.
We'll stay south of your exercise, and we'll be transiting west to east.
And many employees have family members who are part of the volunteer fishing boat fleet that remains at the ready to help in the event of an oil spill.
Well, there's a lot of communities and people in the Sound that's their livelihood. That's how they, make their living, feed their children. So it's very important for us to make sure that oil doesn't hit the water.
But a lot of oil did hit the water, almost 11 million gallons after the Exxon Valdez steamed away from the terminal in 1989 and ran aground.
Well, for me, I'm committed to not allow it to happen again, and I intend to live here the rest of my life.
After Exxon Valdez, the Ship Escort Response Vessel System, known as SERVS, was put into place. Since the early 90s, Crowley has run the tanker tugs and escort vessels. But that, too, is about to change.
We bid it to see what else was out there, and Edison Schwest had the best value for us going forward.
The impending switch to a Louisiana-based company, set to take place in July of 2018, is raising concern among environmentalists.
I just don't think that somebody from Louisiana has the understanding of what goes on in terms of Prince William Sound and the difficulties.
Compounding that concern, Edison Schwest was the company towing Shell's drilling rig, the Culloch, when it ran aground near Kodiak Island in 2012. The Prince William Sound Regional Citizens Advisory Council, set up after Exxon Valdez, wants to make sure the new company's boats and crews are tested, trained, and ready.
It's very important that they hear the concerns of the local people who, especially those that lived through the Exxon spill, that know firsthand the damages that can happen should a spill occur.
We're feeling very comfortable with them, and they bring a world of expertise to this operation.
And while there is debate and many opinions as to who should escort the tankers, there is one priority everyone can agree on. And that's to get the oil in and out of the pipeline's Valdez terminal safely and spill-free. The Trans-Alaska Pipeline has delivered jobs, economic growth, and billions of dollars in tax revenue during its first 40 years. But what about the future? Is time running out for the pipeline? It's a big question, and there is a lot at stake. The numbers that flow from the first 40 years of the pipeline's history are truly Alaska-sized. More than 17 billion barrels of oil moved from the North Slope. 21,000 tankers loaded in Valdez. It boosted Alaska's economy by a full 50%. And through the years has pumped $140 billion of tax revenue into the state treasury.
And after the 40 years, what I'm most proud about is just the benefits that have come from it.
But what does the future hold for Alaska's fountain of fortune?
Hashtag 40 more. I think that TAPS can operate indefinitely, and I think the future holds challenging times with lower throughputs, but someday I hope to see that, flatten off.
Here's the pipeline's track record. Peak flow was 2 million barrels a day in 1988, but overall it's been on the decline ever since. In 2016, the pipeline saw the first year-over-year increase since 2002, up almost 2% to nearly 518,000 barrels a day.
That Arctic is covered with oil and gas.
The late Walter Hickel was governor of Alaska in the 60s when oil was discovered on the North Slope. And he made this prediction just 10 years ago when we talked to him about the pipeline's future.
I'd say 20 years from now, or 30 or 40, most of the resources, oil and gas, are going to come out of that Arctic.
And it looks like Wally Hickel might be right.
The future development is moving more to the west, state lands to the west of Alpine, and then the National Petroleum Reserve.
New oil discoveries in Alaska continue to fuel hopes for the pipeline's future.
I think we could go for another 40 years, at least another 40 years with the pipeline. With the reserves that we do have on the North Slope, they estimate that between offshore areas and onshore areas, there could be as much as 40 to 50 billion barrels of oil remaining in place in the Alaska Arctic.
New oil may be out there, but can a system designed with slide rules and built back in the 70s be counted on to keep that oil flowing safely to market?
There's this tremendous pride, and the pride is not only in transporting the crude oil, but doing it in a way that there's absolutely no impact to the public or the environment.
Many environmentalists praise the pipeline's safety and pollution record so far, but looking forward, they caution against overconfidence.
In terms of complacency, I think, you can go a certain number of years and people will say, well, what's the big deal? We haven't had any incidents. Why should we worry about it? And that is complacency in a nutshell. We should worry about it because the systems are aging.
And as a reminder of what can happen, they point to the pipeline's darkest hours, the Exxon Valdez oil spill.
It's really important that we maintain our levels of safety and not let complacency creep back into the system. We know complacency was a huge factor that led to the Exxon Valdez oil spill.
Certainly the Exxon Valdez was not our proudest moment, but I think in every case we've learned. When we investigate, we apply the learnings, we apply them forward, we don't make the same mistake twice.
And Alyeska Pipeline says combating complacency through training and putting safety as the top priority is a never-ending mission and part of their company culture.
It's just our approach to work is really one of, never really relying on just, we've always done it this way.
As we've seen, there are big challenges ahead. A pipeline designed to carry 2 million barrels of oil is now moving at just 1/4 of that capacity. The resulting problems caused by colder oil, increased deposits of wax contamination and ice buildup are a constant struggle. And the search for dangerous corrosion has led to high-tech testing from the new generation of engineers.
In this location, we have 3 different taps. We have one tap off the top of the pipe.
Figuring out ways to keep the pipeline working. To the pipeline pioneers who overcame amazing obstacles 40 years ago to build it.
I'm glad it's still running at 40 years. I hope it's got another 40 years left in it or more.
Much more than oil flows through the Trans-Alaska Pipeline. For them, it also carries their collective sense of pride in being part of a massive project that some thought couldn't be built, that energized the state's economy and built the personal futures and fortunes of countless Alaskans. At 40 years and still going, it's Alaska's pipe dream come true. As we mentioned earlier, the motto of the people who built the pipeline was, "We didn't know it couldn't be done." As the pipeline reaches its 40th anniversary, that spirit of determination flows on. Thanks for joining us.